In this scene, each box has a numerical identifier inside. This identifier is equal to the A attribute of the box. So how do I find the identifiers of the 4 boxes closest to the pig's head? At this point, we need to use the pcopen point cloud search function and the pcimport point cloud attribute retrieval function. First, we'll pack the pig's head and each box into a point. Add an assemble node to them and check create packed primitives. The box needs to pass the A attribute value. Then, create an attribute wrangle node. Connect the first input to the pig's head. Connect the second input to the boxes. First, define an integer array B. This is where we will store the queried data later. Then define an integer num to temporarily store the queried data. Next, create a handle to store the point cloud query results. Use pcopen for the point cloud search. The first input is the port to query. The second is the default position attribute string P. The third is the default attribute @P. The last two are the search distance and the number of results. We set a 100-meter search radius and search for 4 results. Next, we need to parse the information from the search results. First, create a while loop. Inside, use the pciderate function to loop through the points in the handle. If a point meets the criteria, it enters the following loop body. Use the pcimport function to retrieve the required attribute. The first input is the handle. The second is the attribute namestring A. The third is the custom attribute num for storage. Note that the pcimport function is only effective within a specific loop body. Next, create an append function. Append the searched attributes into the array B. By looking at the final B array data, we can see the identifiers of the boxes closest to the pig's head. The retrieved identifiers are 21, 32, 9, and 12. Now, let's check the scene and see that the closest 4 boxes also have these identifiers. If we change the search quantity to 5, then identifier 3 will be included as well. It's very convenient. This is how we use point clouds to retrieve object attributes. Of course, you can also use other functions. For example, you can use pcfind to search and loop through an array. VEX is very flexible. I hope we can continue exploring. Goodbye.